Hey guys, this is Physics to See. Sorry for the long gap guys, I was quite busy with my college admissions. And today we are going to see an interesting topic. It's not a topic actually. We are going to calculate the number of hair in our head using basic mathematics. We are not going to use any machines or sensors or calculators. So let's have some fun and learning together. Let us calculate the number of hair in our head. So first of all, let us keep it simple. Okay, so the total number of hair in our head will be equal to number of hair per unit surface area multiplied with surface area of your head, the region where the hair is present. Okay. First of all, is this equation correct? So, in order to check whether this equation is correct or not, we can check the dimensionality of the equation. So let us say the number of hairs will be having the same dimensions. So let's rule out of this equation. So we have surface area in right hand side and surface area in the numerator of the right hand side. The dimension of the surface area will be L square and L square. So this is going to cancel and both side is going to remain dimensionless. So this equation is dimensionally correct. Okay. Now let us proceed to the next step. So number of hairs per unit surface area. Okay. Since nature loves symmetry, why nature loves symmetry? Because our nature is designed everything symmetrical, almost everything. Like human body is symmetrical. See, it's symmetrical. So I am going to believe that the hair distribution around my head is going to be symmetrical. So I am just going to assume a constant value like 70 hairs per unit centimeter square. You know what? I don't have a choice, because if I assume some random distribution of hair, the math is going to get complicated, and I hate complications. Just kidding. I love complications, but not in my life. Okay. So what is meant by a uniform distribution of hair? That means, so if the number of hair in some part of the area, like from unit area, is going to be 80, then it's everywhere it's going to be 80 hairs per unit area. That is called uniform distribution. Okay. So let's get into the calculation. Before getting into the calculation, so we have to understand some basics of spherical polar coordinates. Why? Yeah, let us see that. Now let us consider an object, or let's say a cuboid, from a distance of L from the origin. Let's say 0, 0. So let this be a Cartesian coordinates. So we can all easily understand Cartesian coordinates. So this is going to be x, y, z, this point. So it's distance L from the origin. It's nothing but L, the distance, the point, the position vector is going to, of this point is going to be x in x direction plus y in y direction plus z in z direction. So the dimension of this object or box be dy in y direction and dz in z direction and dx in the x direction. So if you want to calculate the volume of this box, we can just calculate the volume length into breadth into height, which is nothing but dx, dy, dz. And if you want the area of the top surface, I mean pointing towards the z direction, this is going to be dx multiplied by dy. So dx, dy, z cap. Similarly, if you want this area, which is projecting towards the positive y direction, so this is going to be dz multiplied by dy. Dx in y direction. So this is the area of these surfaces and this is the volume of the object. So it's very easy to understand Cartesian coordinates. Okay. Now, what if we have a curved object or a curved path? So if you travel in a curved path, we are just going to know the distance of this path, but in order to mention the coordinates of the point, we need the distance in y direction and distance in z direction, and calculating this distance from this path is going to be tedious. That's why we are going to use a different coordinate system, that is known as spherical coordinate system, for dealing with curved objects or curved path. Since our head, let's assume it's the shape of hemisphere, so we are going to have a curved object. So this coordinate system is going to lead us to a tedious calculations. So we are going to use spherical polar coordinates. I forgot to mention the line element. The position vector of this point is L vector, that is x cap, and y cap, and z cap. And the position vector of this point with respect to this point will be L vector plus dl vector. That is nothing but a vector from this point to this point. So this is nothing but the distance in the x direction is dx. So dx, x cap, and dy, y cap, and dz, z cap. So this is the length element or position vector of this point with respect to the origin of this object. Let us understand spherical polar coordinates. In order to calculate the total number of hair in our head, we need to calculate the surface area of the head, which is nothing but the area element, and we can get that from spherical polar coordinates easily. So if you mention a point here, if you consider a point here, in a Cartesian coordinate system, this is going to be represented with the help of x, y, z. That is nothing but, let's say this is the distance from the origin, and let this be the reflection of this point in xy plane. So this is going to be the reflection of this point. So this point will have an x direction, x distance from this origin, and y distance from this origin, and z distance from the origin. So this is Cartesian coordinate system. So now we are going to see a different type of a system. So that is nothing but we are going to, the first element will be the distance from the origin, r. So this is going to be distance r, the magnitude of vector r, and then how much it is rotated from this z direction. So this is z, this is y, z direction. So that is going to be theta, and the direction is this, theta cap. So theta. And third, so this one, the projection of this r in xy plane, let it be p, and the p, how much it is rotated from the x direction. So this angle will be phi, and this direction is phi cap. So this is phi cap, this direction, and this direction from z is going to be theta cap. So these are the three variables which is going to represent a point in a spherical polar coordinates. Now let us just see the distance. What is the distance in towards x direction? So which is nothing but this is r, and the direction, the distance of this vector projected in z direction is going to be r cos theta, and the projection of this r in xy plane, so this distance is p, as we said, this is going to be r sin theta. I am going to say let p be r sin theta. So p. Now we want the x direction, x distance, this distance. So this is nothing but, this is going to be p, and the distance from this point to this point is going to be p cos phi. So x is going to be p cos phi, and the y is going to be, and this distance is going to be p sin phi. From trigonometry, this is our basic trigonometry. And z, this z is nothing but r cos theta. So if you write in terms of r, the radius, r, the distance from the origin, so p is nothing but r sin theta. So this is going to be r sin theta cos phi, and r sin theta sin phi, and r cos theta. So this is the distance from this in Cartesian coordinates. this one, and this one. Z, X, Y and Z. So if you want to write in terms of Cartesian coordinate, in X term we should, in the place of X we are going to write this, and the place of Y we are going to write this, and the place of Z we are going to write this. The line element in a Cartesian coordinate system was, as we saw, dx in x direction plus dy to y direction plus dz to z direction, the line element of that volume. Similarly, in the line element of this same volume, of the curved volume in polar coordinates, spherical polar coordinates, is going to be, let's see, so x, y, z in Cartesian. Here, so in spherical polar coordinates, we have to represent in r direction, theta direction and phi direction. The r direction is nothing but this one. So this is the r direction, direction of r cap, r direction. So the distance is dr, it's going r, so it's going to be length element, it's going to be dr, dr r cap, plus theta direction. Theta direction is this one. So this one, if the r is rotated in this direction, so what is this length? This length is going to be, if this is r and this is r cos theta, so this is going to be r sin theta. But for a small angle, so we are going to do small element, small angle, r d theta. So for r d theta, so r sin d theta is going to be d theta. So r d theta into theta cap plus phi direction. Phi direction is this one. This is nothing but, what is this? R sin theta, P into this direction. If this is P cos theta and P cos phi, this is going to be P sin phi. But for a small element, so P sin d phi. So sin d phi is going to be d phi for a small phi, angle d phi. So this is going to be P phi cap, sorry, P d phi, phi cap. So dl is going to be dr r cap plus r d theta and theta cap plus P is nothing but, what is P? P is r sin theta. R sin theta into d phi, phi cap. So in that we wrote the line element in polar coordinates. Now I have to calculate the surface area of my head. So I am going to assume the shape of my head as an hemisphere. So the shape of my head is just an hemisphere. So hemisphere. So I need the radius r of my hemisphere, which I will just assume some centimeters. Yeah, I will calculate it. So now we want this area, this curved surface area in which the hair is present. So this curved surface area is r cap, projected in r cap. We saw in Cartesian coordinate system that if you want an area projected in y direction, so we are going to multiply dx and dz, which gives the y cap. This will give the area element to y cap. Similarly, if we want the area which is projected in r cap, so we are going to multiply by leaving this r cap, we are going to multiply the line element of theta direction and phi direction as we did in Cartesian coordinates. So the area element is going to be r d theta, r sin theta, d phi. So r square sin theta, d theta, d phi. So this is the area element and projected towards r cap, r direction. That is nothing but the radial direction. Now let us measure the radius of my head. In order to measure the radius of my head, I cannot calculate it directly. So what I am going to do is, I am going to measure the circumference, that is nothing but 2 pi r, and from that measurement I am going to calculate the r. So I am just using some tape, random tape to measure my circumference. So this will give me the approximate circumference, so of my head, and I'm going to mark it, and then I'm going to measure it with the ruler. So it's 30, and from here it's going to be 26. So the 2 pi r is going to be 30 plus 26, which is 56. So r is going to be 56 divided by 2 pi, which is 56 by 6 will be 9 point something. So since I don't have a calculator, so I'm going to approximate it to 10 centimeter. So the radius will be 10 centimeter. Now let's calculate the number of hairs per square area, per unit surface area. So let's take a number of hairs for a centimeter square. I love to handle things in SI units, so centimeter, meter. So for 1 centimeter, if you assume like 10 hairs and 10 hairs in this way, or 12 or 12, so let's keep 12. So it's going to be 144 hairs per centimeter square. So if you round off, we'll keep 150. So in order, I don't have a calculator as I said, so number of hairs per area is going to be 150. Now with this, we can start our calculation. So total number of hairs is going to be number of hair per unit surface area, that is nothing but 150, as we assume, 150 hairs per centimeter square into the area element r square sin theta d theta d phi. So d theta and d phi are variable, so nothing but the theta angle and this phi angle, azimuthal angle phi, as we see, these are variables. So if we integrate d theta from 0 to, this will be 90 degree. So we assumed an hemisphere, for perfect hemisphere. So theta will shift 0 to 90 degree. And this phi, so this phi angle is going to rotate a complete rotation of 0 to 260 degree. That is nothing but 2 pi. So if we calculate this integral, so we are going to get 150 into r square into the integration of sin theta is cos theta, and cos theta from pi by 2 to 0 will give you 2, and d phi is integration is phi, and 0 to 2 pi is going to give 2 pi. Okay, sorry. So integration of sin theta is minus cos theta, and from pi by 2 to 0, which is going to give cos pi by 2 is 0 and cos 0 is 1, negative outside, so it's going to be plus 1. So this will give the total number of hair. What is radius? As we see, 10 centimeter. So if we calculate it, 150 into 10 centimeter is 10 into 10 is 100 into 2 pi. So pi is 3.14 something. So I don't have the calculator as I said. So 10 into 10 is 100. 100 into 2 is 200. 200 into 3 is 600. So 150 into 600, which is going to give you, so which will be giving 6 into 15 is 90. So followed by 3 zeros. So approximately 90,000 hairs. So we just calculate the number of hairs in my head, that is nothing but 90,000. So if I take the account of this 0.14 decimal, it's just going to be some 92 to 95,000. I don't think so. But yeah, so this is how we calculate the number of hair in our head using mathematics. So for an average person, it may, like the dimension of head, the radius is going to change, or the number of hair per unit surface area is going to be changed. So the average value is just going to be from 80,000 hair to 1,10,000 hair. So minus 90,000 as we calculated according to my mathematics. Thanks for watching, guys, and if you like my video, please subscribe to my channel and share it with your friends. Thank you.